Now that you know about current and voltage, let's try to understand about resistance. If you have no idea about current and voltage, I would suggest you to watch my previous video by clicking here so that you can get an idea about it. So now coming back to the topic resistance, as the name suggests, it's kind of an obstruction to the flow of anything. In terms of electronics, resistance is an obstruction to the electron flow. So why do we need resistance? If you remember from the last video, the number of electrons flowing in a wire decided the amount of current flowing in amperes. Like 1 ampere is equal to a flow of 6.2 into 10 to the power 18 electrons flowing per second. So to understand the need of resistance, let's go through the water logic again. Let's assume there is a bottle whose capacity is 1 lakh water molecules and you try to fill in 5 lakh water molecules. What will happen? Yes, the bottle will blast. Likewise, every electrical component that you will connect to current through a wire will have a capacity. A bulb with capacity of 1 ampere shouldn't be connected to something which can provide more than 1 ampere of current, or else the bulb might get damaged. So resistors are basically components which can limit the amount of electrons flowing in a wire and thus limiting the current flow. So resistance value of a resistor is measured by the unit ohms, whose symbol looks like this. And we can get all varieties of resistors based on how much current you want to limit. Now you have learned the 3 most fundamental concepts of electricity, that is current, voltage and resistance. Now that you know all the 3 terms, let's combine them and make our first circuit. Every circuit has its 3 important parts, first being the voltage source or the battery in this case. Second is the path for current to flow, which is the electrical wire in this case. And last is an electrical device or load which consumes electrical energy. For any circuit, the current flowing in the circuit I is directly proportional to the voltage V. Like in our water logic, the water flow is directly proportional to the pressure difference in 2 tanks. Like in this case, the pressure difference is less, so less water flow rate would be there. And now the pressure difference is more, so more water flow rate would be there. Likewise, every voltage source like a battery has a fixed capacity of how much electrons it can push. That is the maximum current that it can provide. For example, we get 2 kinds of pencil batteries in the market, AA size and AAA size batteries. Now both of these batteries has the same voltage rating of 1.5 volts, but the AA size battery can provide more current than the AAA size battery because of its bigger size. Now coming to simple circuits, there are 2 types. First is a closed circuit where there is a continuous path for the movement of electrons. Second is the open circuit where there is no continuous path for electron flow and hence no current flow. Now considering a closed circuit, there is a voltage source and a load. Let's assume that the bulb's capacity is 0.5 amps and the battery can provide a maximum current of 1 amps with a voltage of 1.5 volts. So we have to restrict the current in the circuit to 0.5 amps so that the bulb doesn't get damaged. That's why we have to add a resistance in the circuit which can bring down the current. It doesn't matter which side you put the resistor, it works the same. Now the next question is, which value of resistor is to be used, which can bring down the current from 1 amp to 0.5 amp. So this is where Ohm's law is useful. It frames a relation between voltage, current and resistance, and the formula is V equals to IR. Let's see how to apply this formula on a simple circuit with a voltage source of 9 volt, a load like LED bulb and a resistor to limit the current. Now we have to find the value of the resistor using the formula V equals to IR. Now looking into the datasheet of an LED, we get to know that its current capacity is 0.02 amps and its voltage drop is around 3.3 volts. Confused about voltage drop? Every component in a circuit consumes some voltage, and that amount is called voltage drop, and that is 3.3 volts for an LED. Now coming to the formula, here V equals to total voltage, that is voltage of battery minus voltage drop, that is 9 minus 3.3, which equals to 5.7 volt. So I is the required current, which is 0.02 amps. So using the formula, resistance equals to V by I, that is 5.7 by 0.02 gives 285 ohms. So we have to connect a minimum of 285 ohm resistor to keep the LED safe. So this is how you solve a circuit. So in the next video, we'll be learning about Arduino basics. So that's it for this video, and thank you for watching.